Okay, so we are starting kind of like the second piece of chapter 8, which is on parametric functions. And these first bits, again, are full of a lot of definitions. And so I find it to be a little bit confusing. I'm hoping that I can help kind of clear up what a parametric function is. So like your textbook describes that like relative positions of airplanes are dependent upon their velocities at a given moment in time and their starting positions. So vector equations and parametric equations, they can model movement with time. So before we were just talking about, an airplane's going here, here, and here, but we really didn't have anything to do with time. So this introduces a new variable for us, and that's t, and that almost always stands for time. Okay, so that kind of makes sense. So here's where the definitions come in. So if a line with points P1 and P2 is parallel to a vector, we'll name the vector A, we can write a vector equation as the line P1, P2 that goes through those points equals time times vector A. Okay, so that's what we're going to be doing now. So I'm going to give you an example here. My example, I'm going to give you a point 1. My point 1 is 1, 4. And up in my definition, I had point 1 and point 2. Point 2 is honestly just going to be xy. And I don't ever give you the point 2, so it might be helpful for you if you just write down that point 2 is xy. And I want you to write a line or write the vector equation for a line that's parallel to vector 3, -2. So one thing to remember that if we're finding like the distance between these points on a graph, like for example, if one of them was 3 and one of them was 1, the distance here would be 2, and we would subtract 3 minus 2. So in that same way, like the distance between point 2 and point 1 is x minus 1. And the distance between in the y direction, like between y and 4, is y minus 4. Okay, just like we would subtract these, you would subtract those. So when I write this equation here, this vector equation, my x is x minus 1 because that's how I would find the distance between x and point 1. My y is this, and it equals, so that's this part here, t times my vector a. That's this part right here. Okay, and this comes from, this is just kind of like the basic definition, okay? So then, so this is vector, and make a note of this because here's where things get tricky. I'm going to ask you to use this whole thing here is your vector equation. I'm going to ask you to use this to now write the parametric equation. So I'm going to switch colors here for you. So now we're going to write the parametric equation, which means we're going to add in t into our equation, okay? So I basically have two pieces. Parametric equation will always say x equals and y equals, and it will always be in terms of t, okay? So I'm going to take the x portions and say that they're equal to each other. X minus 1 equals t times 3, and I'm going to solve for x, so I would add 1 to both sides. So x equals, and I like to write this as 3t plus 1. Then same for the y's. I'm going to take the y's, and I kind of got to keep that t in there. Y minus 4 equals t times -2, and I'm going to add 4 to both sides. Okay, these are your parametric equations, okay, these two things. And you would write them on one thing like this, x equals 3t plus 1, and y equals minus 2t plus 4. Okay, t, why is it called parametric? T is the parameter. parameter. If I ask you to find the vector equation, so this is what like a homework. So I'm going to find the vector equation, the parametric equation, and then make a table. This is going to be like an example homework problem. Okay, first thing I'm going to give you is the point. Point 1 is -2, 4. -4, sorry. And point 2, remember, x comma y. I'm never going to give you that one. And I want it to be parallel to vector. Do I have a vector written down for myself? 6, comma, -3. Okay. So write the equation, write the vector equation of a line that is parallel to this vector and goes through this point. So remember, I first need to find how far these 2 points are. So that will be x minus -2, y minus -4 equals t times my vector a. Okay, so this gave me this. This gave me this. This is the vector equation. Okay, now I'm going to take my orange color. The parametric equation is when we split it into its x and y pieces. So x minus -2 is really a plus, right? I hope everyone's okay with that. And I get x equals 6t minus 2. Then y plus 4 equals t times -3. Y equals -3t minus 4. These are your parametric equations. How then do we make a table? When you make a table, your new independent variable is t. So your t table now has t, x, and y, and you get to choose the t's. So I'm going to choose these maybe, as many or few as you'd like. And then plug it in. So when I plug in 0 to my x equation, I get -2. When I plug in 1, I'm plugging these numbers in right here. I get 6 minus 2, which is 4. When I plug in 2, I get 12 minus 2 is 10. Okay, same now. I'm going to take these numbers and plug them in over here, but now for y. So I get -4. So minus 7, minus 10, and minus 13. I think I did that correct. So making a table, you could come up with that. You could graph this table. There will be no like t on your graph. So just like -2, that one won't fit. Of course, I did my graph wrong. Okay, but there's no t on your graph. It's still x and y. Okay. The last bit of the lesson that I want to show you is just about switching, converting between parametric and rectangular is what we would call them. And you guys think of these rectangular. You guys think of these as more like our normal ones. So what we need to do first is to well, I probably should give you the example, -4x plus 7. And I want you to convert this to a parametric equation. So change to. Okay, first, let x equal t. Okay, just start there. It's super simple to substitute. Okay, so I'm going to say x equals t. Y equals -4t plus 7. That's all you got to do for that one. That one's not so bad. Okay. If you get something in standard form like 2x plus 3y equals 6, you first need to change it into y equals before you can move on with this process right here of changing it into parametric by saying x equals t, because you need to give me. Parametric means having an equation where x equals something and y equals something in terms of t. Okay. If you have to go the other way, okay, so I give you, for example, I give you the parametric x equals 2t, y equals 1 minus t. My first step here is to solve for t. X equals 2t divided by 2. t equals x over 2. Now you're going to use substitution again. Similarly, don't you see these steps kind of match? I'm going to plug this now into my y equation. So y equals, and I need to have a y equals 1 minus, and t is x over 2. Okay, I can leave it like this. You could say 1/2 x. You could change it around, but this is your answer where you've kind of gotten rid of the t. No t in rectangular form. All right, I'll leave your homework assignment and an answer key for you.